All right, so this is the start of the FRQ. So the context tells us that Stephen is swimming back in a pool for 90 seconds, and it gives us the velocity function. It's important to note that we have the velocity function, not the position, not the acceleration. That way we know if we want to find the acceleration, we only need to find the derivative of the velocity, not two derivatives. Just helps us find where we are before we start. And so for part A, it's asking to find all times when he is changing direction. So what we're first going to want to do is set the velocity function equal to 0, because anytime an object changes direction, there's going to be a point where they are going 0 units per time measurement. So we can say set v of t equal to 0. And this isn't anything that we can solve by ourselves. So we're going to want to put this into a calculator. You can do this on your calculator or go to Desmos. Just type it in, and then you can visualize it, or you can use tools to find what the x-intercept is. But it says right here that t is equal to 56 will make the velocity equal to 0. But however, there's another criteria we need to consider. We need to make sure that the velocity is changing signs around 56, because that means that he's going to be going, for example, to the left, and then he switches to the right because the velocity is changing signs. So maybe negative could be to the left and positive could be to the right. But if we check right here, we can see very clearly that right here is above and to the right of it is below. So very clearly he's changing direction at time t equal to 56. And so that is our answer.
For this question, you get 1 point for considering the signs of the velocity function and another point for getting the correct answer. However, you have to justify your answer in terms of the velocity function changing signs. Obviously, you know that I was considering the velocity function signs because I was saying it out loud. However, the AP readers can't read your mind. So on the AP test, you have to make sure to write out why t is equal to 56 is the correct answer in words. If I hadn't justified my answer out loud and just turned in the paper, I likely would not receive full credit.
But it also intercepts at t equals 0. Why doesn't that count?
Well, 0 is actually not in the domain. Pay attention next time.
Ready to go to the next one?
Okay, so for part B, it's asking us to find the acceleration at time t is equal to 60. So it's important to note that since we're given the velocity function, which I wrote below, we need to find the acceleration function. And thankfully, it's really easy to find the acceleration function because it's just the derivative of any velocity function. So what we're going to want to do is derive this function right here. And we can see that we have a function right here and a function right here that are being multiplied together. So we're going to want to use the product rule, which can be represented as ab prime plus ba prime. So if we let this be a and this be b, we can just solve this, which is going to be 2.3. Sorry, put the wrong constant there. 2.38 e to the power of negative 0.02 t times the derivative of b, which is cosine of pi t over 56, chain rule, which is going to be the derivative of the inside, times pi over 56, plus b, which is just the function of pi t over 56, times the derivative of a, which is 2.38 e to the power of negative 0.02 t, and then we have to use chain rule and derive this part right here, so times negative 0.02. Okay, and then we're looking for the acceleration at time t equals 60, and so since this is the acceleration equation, we want to graph this, which you guys can do in your calculator, and then find when time t is equal to 60. And so I already graphed that out. I typed it right here. And then if we zoom in and look for the point at 60, we can see that it is about negative 0.03602, and that checks out. So the acceleration a of 60 is equal to negative 0.036. And we'll say approximately equal to negative 0.036. All right, now it's time to interpret our question, and we can check and see from the first equation by plugging in the graph that the velocity at v of 60 is also negative. And since these signs match, since the acceleration and the velocity are both negative at 60, we know that it is going to be speeding up. So we can say that at time t equals 60, Stephen speeds up. And that's part B.
For this question, you get 1 point for finding a of 60. While not necessary, it's definitely going to help you to state clearly that v prime of 60 is equal to a of 60. However, if you clearly show that you're deriving the velocity function and then plugging in 60, like I did, you should be fine. And then you're going to get the next point for answering with units in terms of the questions, and that's something that I forgot to do. So make sure that you're including meters per second squared after your answer. Finally, you get a point for justifying why Stephen is speeding up, and you have to say that because v of 60 is negative, and the acceleration at 60 is also negative, then he's going to be speeding up. Again, I clearly mentioned out loud that the signs must be matching for him to be speeding up, but on a test, you and I should both write out in words that that is the reason why he's speeding up. That way the graders aren't confused as to our logic and reasoning behind it.
Yeah, Henry?
How come velocity and acceleration have to have the same sign?
Well, let's say I'm moving one direction and I start accelerating the other direction. I wouldn't be speeding up, I'd be slowing down.
Oh.
Okay, so are you ready to move on to the next question? Okay, cool.
Okay, so for part C, it's asking to find the distance between his position at time t is equal to 20 seconds and his position at time t is equal to 80 seconds. And so if we let p of t equal to position, basically the question is asking what is p of 80 minus p of 20. And so since we're not given the position function, we're going to have to think about how we can write this. But we know by FTC that the integral from a to b of a velocity function is going to equal to the position at b minus the position at a. And this works and checks out perfectly because we know we have two position places here. So all we got to do is change the bounds right here. And so we can say that the integral from 20 to 80, because those are the 2 points it's asking for, of the velocity function, I'm just going to shorten that right here, but that's going to represent what's given above, is equal to the position of 80 minus position at 20. And we can double check, but this does equal this right here.
Oh.
So now all we got to do is solve for this integral right here, and we can tell that that's going to be the difference between where he is at those 2 points. So what you guys can do to solve it is go into your calculator, press math 9, and then type in the bounds, and then type in the function. And I already wrote it out right here, but that's going to give us 23.3839. So we can say that that is equal to about 23.384 meters. Make sure to include your units because this is a real life situation where he's going back and forth and you can actually visualize his swimming.
This question is very simple in terms of grading. You get 1 point for setting up an integral from 20 to 80 of the velocity function, and then 1 point for getting the correct answer with units. If you got a different answer, namely 2.407, you may want to switch your calculator from degree mode to radian mode. If you struggled with this question, you should work on setting up and understanding what integrals represent.
Wait, one more question. Why don't you write this neat on tests, Ian?
Yes, you caught me. Although you caught my disguise, there's still one more question. Let's go do it real quick.
Okay, so part D is asking to find the total distance that Stephen traveled in the first 90 seconds. And so, while we might think that we might just want to take the integral from 0 to 90, it's important to note that if this is the pool right here, and let's say that this is Stephen, and he's traveling right here, he's 50 meters away from where he started. But then if he goes right here, he'll have traveled a total of 100 meters because he's gone 50 and then another 50. But he's only going to be at 0 meters from where we started. So if we just take the normal integral, that's going to give us 0. And we don't want that because that's not going to make sense in the context because he hasn't traveled 0 meters. He's traveled like 100. But so the way that we can account for this is because right here on this part, he has a negative velocity. If we account for that and make it positive instead by using absolute value, then that's going to take care of the total distance traveled. So we can write that the integral from 0 to 90 of the absolute value of v of t is going to equal total distance traveled. So we can plug that into our calculator. Same thing as the last question, just to press the math button and then 9 and then put in your bounds and then make sure to do absolute value. But if we put that in and we put the absolute value bars and then make sure to derive in terms of x, we're going to get, which is approximately equal to 62.164 meters. So in the context, he's traveled about 62.164 meters in those first 90 seconds.
This question is also very straightforward in its grading. However, it's very easy to miss simple points as it offers no leniency or follow-through points. The first point is earned for setting up the integral from 0 to 90 of the absolute value function, and the second is earned for getting the correct answer. This is why it's super important to know how to use your calculator, because you could miss half the points just by making an inputting mistake, even though you knew the correct setup for the question.
This was really hard for me. Are there any other ways I can practice?
Well, one good practice is the first question of the 2011 Calc AP FRQ, but you can also check the link that I posted.
Ooh, I'm so excited. I'll go do those right now.
You know, I actually had a couple questions about Taylor series. Do you think that you have any problems that you could help me with?
Yes, of course. Watch the video I recorded to do a practice Taylor series FRQ.